Hello, my name is Christian and I'm the CTF noob. Today we're going to have a look at the 7th Narnia challenge from OverTheWire, and this time we're going to use a return to libc attack. As always, I'm no security professional, hence the CTF noob, but I'm interested in IT security and try to share what I learned so far. So let's get started with Narnia6. As always, we start by inspecting the challenge files and have a look at the source code. In line 16, the program starts with a couple of imports of standard library stuff, so that's something we should keep in mind. In line 20, environment is declared as externally defined. Now we know that environment variables will be used in some way. In line 24, we can see some inline assembly, which seems to save the stack pointer in EAX, which for now should not be important to us. Let's have a look at the main function. In line 31, main starts by defining two 8-byte character arrays, B1 and B2. The following line 32 is a bit tricky. It starts by defining a function pointer to a function that returns an integer and takes a C string as input. The function pointer then is pointed to puts from the C standard library, which is properly casted so the function pointer works as expected. Afterwards, simply an integer variable with the name I is declared. Now, line 34 checks if the program is called with two parameters, and if not, exits with exit code -1. Then, in line 37 and 38, the environment variables are zeroed out with memset, as the comment in line 36 states. Afterwards, all parameters after the first two ones are zeroed out, just like the comment in line 39 states. Now in line 43 and 44, the first two parameters are copied into B1 and B2 respectively. Since line 45 is commented out, the code resumes in line 46. There, for some reason, the frame pointer is compared with the stack pointer, and if they match, the program exits with exit code -1. I'm not sure why this is done, but let's move on. In line 49, fp is called with B1, which is the first parameter provided to the program. Finally, in line 51, the program exits with exit code 1. It seems like there is no way to inject our own shellcode. The two 8-byte character arrays are simply not big enough. The other parameters are overwritten with zeros as well as the environment variables. We need to find another way to attack this. In hacking the art of exploitation, I read about a technique which is called return to libc. Instead of using our own shellcode, we'll try to redirect execution to the C standard library function system, which we'll use to give us a shell. But how exactly can this be achieved? We need to find a way to override the function pointer fp with the address of system, which is defined in stdlibh. Then we need to make B1 contain a string like /bin/sh to make system open a new shell for us when fp is executed in line 49. We first have to find the address of the function system. For this we start Narnia6 inside of GDB, and as always set the disassembly flavor to Intel in disassemble main. We can set a breakpoint anywhere in the program and run it with the two required parameters. When the program stops, we can use the p command to retrieve the address of system. In this case, that's F7E4C850. Now that we know where to find system, we need a way to override the function pointer fp. For this we start a program again, but first we will delete the initial breakpoint. We set a new breakpoint right before the function pointer is executed. This way we should be able to analyze the stack and find a way to override the function pointer. Now we run the program again with the two parameters, and at the breakpoint list the registers with info registers. EAX contains 8048430. If we again have a look at the disassembly, we can see that EAX is calculated at main plus 316. Let's analyze the stack further and inspect what EBP-OXC is. Well, just as expected, we see the address 8048430, which should be the function to be called one instruction later. Maybe there is something interesting before this position in the stack, so let's subtract 8 bytes more and have a look. Interesting, we can see 4 41s after another. This must be the 4 A's we entered. So we should be able to let the parameter overflow into fp, since the string copy does not check for the length of the arguments. Let's try it out by appending 4 more A's and then 4 C's for the return address. As expected, the program segfaults at 43, 43, 43, 43. So now we are able to overwrite FP with the address of system. We replace the 4 C's with the address we found earlier and restart the program. The shell process tells us that something was not found. So system is executed, but we must provide a parameter to execute, just like the documentation of system states. Since system tries to execute a couple of A's, we can be sure that the first program argument is also the parameter to system. But we can't end the parameter with the required null byte, so there must be another way to write the parameter. Let's start the program again, but this time analyze the stack even before buffer B1. We can see that 42s and a little bit later the 41s. So we should be able to overwrite B1 by overflowing B2 into B1. Let's try it out by appending 4 more B's to the second parameter. Instead of 4 A's, we can only see 3 A's and a null byte. With this information, we should be able to properly overwrite B1. We simply have to append /bin/sh to the 8 B's. This overflows B2 into B1, resulting in B1 consisting only of the string /bin/sh followed by a null byte. And as expected, we gain a shell. Let's try it outside of GDB. And there it works too. Let's quickly get the password for narnia7 and we're done. I hope the return to libc technique was as interesting for you as it was for me. When reading Hacking the Art of Exploitation, I learned a couple of cool things, so I can only recommend this book. If you found this video interesting and could learn a little bit, please give this video a like, and if you want to see me solving more CTF and wargame challenges, please subscribe to my channel. Thank you and until next time.